So the modulated signal is equals to m of t into c of t. As we know that c of t is a very high frequency carrier, let us consider c of t to be some sine or cos 2 pi of ct. Okay, then s of t is equals to m of t into cos 2 pi of ct. Now applying Fourier transform on both sides, so s of f is equals to m of f minus fc plus m of f plus fc. This is 1 by 2. This is the Fourier transform of the signal. This is according to the modulation property of the Fourier transform, and if we consider the spectrum of this wave, the modulated wave, it will be this is s of s, and the signal will be this is minus fc and this is plus fc. So when we do the modulation, the spectrum which is actually like this will be shifted to plus fc units and minus fc units, and the amplitude becomes half of the original value. Okay, and the amplitude becomes half of the value. This is called DSP signal. Now, the modulation definition is, this is one of the definition of the modulation what we have considered here. And now the modulation definition is changing any one of the parameter of the carrier, that is either amplitude, frequency or phase of the carrier with respect to the message signal. If we vary the amplitude, it is called AM, and if we vary the frequency or phase, it is called angle modulation. So in AM there are some disadvantages are there, and to overcome those disadvantages we consider DSP signal, DSP-SC, double sideband suppressed carrier, and SSB-SC, single sideband suppressed carrier, and VSP. These two are used for voice communication, that is voice communication, voice transmission, and this is used for video communication, video transfer. Coming to amplitude modulation, that is AM. In case of the amplitude modulation, the amplitude of the carrier is varied in according to the message signal, that is, and the time domain representation of AM, this is S of t, AM is equals to AC into 1 plus KA M of t cos 2 pi f c. AC into 1 plus Ka M of t cos 2 pi f c. Here Ka is called amplitude sensitivity factor. This is called amplitude sensitivity. We know that as this is the carrier wave, and the amplitude of the cosine signal is AC into 1 plus Ka M of t. This amplitude depends upon the message signal M of t. So it is called amplitude modulation. And if we expand those expression, we get AC cos 2 pi fct plus AC Ka M of t into cos 2 pi fct. this expression earlier we have considered, this is nothing but the DSP signal, and if we add the carrier to the DSP signal, it will become amplitude modulation. The purpose of adding this carrier is to easy the demodulation of the wave. Now this is the AM signal, and we have to consider the spectrum of this AM signal, from which we can get free bandwidth and the power required to transmit the AM signal. Now to draw the spectrum, we have to apply Fourier transform on both sides. If we apply the Fourier transform on both sides, we will get expression like this: delta of f minus fc plus delta of f plus fc plus AC Ka by 2 into m of f minus fc plus m of f plus fc. So now let us draw the spectrum of this wave. Before drawing, let us consider the spectrum of the message signal is like this. Then the maximum frequency present in the message is W. Now the spectrum of the modulated wave, which is AM, is the original message signal spectrum will be shifted by plus fc units to the right side and minus fc units to the right side, and the amplitude of these peaks will be Ka into AM by 2, and this is AC by 2, and this is AC by 2. From this, and this will be Fc plus W, and this is Fc minus W, where W is the maximum frequency of the message. From this, we can easily find out that the bandwidth required for the transmission of AM signal is high frequency minus low frequency. Then we will get 2W bandwidth for the transmission. 2 into W is nothing but the highest frequency present in the message. Frequency present in the message is the bandwidth, and let us consider the power calculation. Power. So